Just started. All right, that's started. Step one. So what does step one say? So your axial load is what? Now, your mx is your moment about your major axis. Are you with me? Your mx is your moment about your major axis. So what's your mx? What's your my? Eh? So what's your step two? So now, trial section one. Trial section one. 305 by 305 by 118. So this is my own trial section. That is going to fail, yes. Bele carbon. Now, so it says we should classify it Abi. Now, the classification of this one is the one that you know. Are you with me? You know, I said the one we did earlier, the way he classified it is totally somehow. So I said we should not do it, right? Until we have total clarification from him. But this one is the same way that we did before. So for this one, you classify for your flange, you classify for your web, you classify for entire cross section. Let's do it now. Ekin is fast now. Let's do it together. Bawo. You should be fast with it now if you did your assignment. All right. So flange. Now, first of all, this thing, it has what? It has axial load and what? Bending. So for our web, we know what we use generally. If you don't understand anything I'm saying now, that means you are not in last class or you did not do your assignment, one of the two. So now, let's do our flange. So before we do our classification, what are the parameters we need? We need our py, we need our epsilon, right? So now, what's our material thickness for this question? What's our material thickness? Material thickness is the highest between what and what? So what is it? Now, what's the next thing you want to do? Your design strength, which is what? Py. Going to table 9, it says for road I section or H section. Are you with me? For road section generally, your material thickness should be less than what? What's the first one? 16. And that will be what? 275. Is it less than 16? Is it less than 40? So that will be what? 265. So let's do our epsilon. Formula for epsilon is what? 275 over py raised power 0.5. This should give you 1.02. Am I correct? Now, let's classify for our flange. Please, what's this noise? Classification for flange. What's our B over T? 8.22. Good. Now, for class 1, 9 epsilon. So that's 9 times what? What would that give us? So, and what's the check? Ratio less than what? Limiting value for it to pass, right? Let's do our web. Do you understand this? This classification, we've done it last week. Oh. You did not open it, right? Now, I said what we use for web. What type of this thing are you doing? The column, how is it loaded? Axial load and what? And bending, right? That's the moment. Axial load and bending. So for your web, what will it be? You know, for web, you have what? You have at mid depth. You have generally, and you have what? Axial compression. What causes at mid depth? What causes at mid depth? Pure bending. Pure bending, that is just moment. It will give you what? At mid depth. If it has more than one this thing, more than one loading, which is what this case, it will be generally. I explained last week. Oh. Then under pure axial compression, it will be what? Axial compression. So you understand why I want to use generally now. You did not understand. Now let's find our R1. Yes? What is your question? That thing I just said. Did you write last week? Do you understand? Why didn't you write it when I was explaining last week? Let me come again. Let me come again. Under pure bending, that is under the application of moments, just bending. Under pure bending, your web, it will act as your bending will act as what? Neutral axis at your mid depth. But when you have more than one load acting on this thing, that is, you have bending, meaning you have moments and you have axial load. You do what? Generally. Why under pure axial load, under pure axial compression, that is under just, let me explain what I'm saying. If you have just this, just moments, your neutral axis will be at what? Mid depth. That's what you use for your web. If you have this and this, the two, in this case, what's the title of this thing? What's the title of this subtopic? Under subjected to what? Member subjected to what? Are you with me? Member subjected to what? Axial load and what? Bending. That's why we are using generally. I said if you have more than one load acting on something, use generally for your web. The third one is what? Axial compression. That's when you have only. I'm very sure I said this last week, right? Good. If I have to say it next week again, next week we are going to do connection. I will still use all of this. Now, you shall know I got this. Now, the value of my R1, please go and check. What's the clause for the R1? Let me see if you still know where it is in the table. Did I send you? I don't say you should say the section for us. You people on this column, you people like this. You people on this column, what's the clause from these two rows? What's the clause for R1? That's where you check your clause, Abi. Oh yeah, be checking it.
No, I wrote it.
No, just these two rows.
3.5.5.
That's the clause.
Yes.
And what's the this thing?
FC over DTPY.
What's the clause for this R1?
3.5.5.
Who wants to help her? I'm not asking what is the clause for this whole thing. What's the check? Oh yeah, what's the check?
minus 1 less than R1.
Yeah,
less
correct
than-
this.
Huh?
F9, correct this.
Anything, now, let
Oh
me
yeah, oh
see.
yeah. Did I ask you? Ah. You know we've not started solving this thing. Instead of you to do it, initial account, you did not see classification to do in second week. What's your entire cross-section classification? Yes. What's your entire cross-section classification? How do we get class 1 plastic?
Because it's close on that class.
Did I ask you? You're answering week 1 this thing, you're happy. All right. So I don't think you should have issue with this one. You can go and do this on your own or something, or you snap it because I'll soon clean it. It's just classification. Now, what's your next step? I don't want us to waste any more time. You should know how to do this, right? So now, for moment capacity, go to 4.2.5.2. You know that one now. We did it last week too. That is local cross-sectional resistance. I told you it's the same thing as moment capacity, right? Plus 4.2.5.2. Are you there? So and when you want to do this local cross-sectional resistance, are you with me? Which one will you use to use that? Which one will you use? Like what classification will you use to know that, okay, this is the formula I'm using for my local cross-sectional resistance? That's all. You're not. If you want to do local cross-sectional resistance, which of all of this classification will you use to know the one you use to classify for your local cross-sectional resistance? Entire cross-section, thank you. The classification you got from your entire cross-section is what you use to get the formula for your local cross-sectional resistance. Shiwenyin. Okay. You still don't understand what I'm saying? Open your notes, the last class. You understand? I'm sure you wrote it. Step 3. So what's your formula? MC is equals to what? Now, in this case, listen. In this case, we'll be solving for both axes. That is MCX and MCY. So this formula will now become MCX is equals to PYSX. Are you with me? And MCY is equals to what? PYSY. Now, what is S? What is S? Plastic modulus. So you have for X axis and for what? Y axis. Have I lost you at this point? Yes. Where did I lose you? Where? Where first? Yeah. Everywhere. If I lose you in section classification, I cannot lose you. It's not possible for me to lose you in section classification because that's not this week topic. You were not in last class. You were here last class. You stopped where? Which place confused you? You remember how to get your parameters. You remember this one, but you don't remember this one. Wow. Now I don't know how I'll start this thing. Maybe we can meet them. Like meet them after. Now, what was your value for your MCX, please? First of all, what's your SX? Your SX is what? 196. Okay. What's the unit? And your SY is what? Now, let's get our MC. Our MCX, Jerry. Our MCX will give us what? What's our PY? What's our PY? 265. 265 times 1960. And I said to turn all of this to kilonewton meter, just multiply outside times 10 power minus 3. What did you say? MCX will give you what? 519.4 kilonewton meter. Now, let's do your MCY. What will you get? Do your MCY. What will you get? Correct. You know, when we were doing it last week, are you with me? When we were doing what's it called? Section classification, I told you that when you get to this point, right, you pick the highest value for your S. And if you have the one that has Z, that should be your axial compression. You pick the highest value too, right? I said that one is just for that topic. I think I said that particular rule is just for that topic, right? That's why this one is changing. This one, you are doing it for two axes, MCX and MCY. Same way we've been working with two axes, MX and MY. Good. So what's our MCY again? Have I lost you at this point? Have I lost you at this point? Up to this point? Orenla Oluwa, will you like to come and collect the marker? Have I lost you at this point? Now, there is a check at this point, right? What's the check? Hello, one house. One house. What's the check? Eh? Yeah, check it. Does it pass? Is MX greater than MCX? So our MX is lesser than MCX. That passes. Is our MY less than MCY? That passes as well. The only time it will not pass, please read that thing very well, that check very well. I said if either MX is greater than MCX or MY is greater than MCY, you go and pick another section. Do you understand what I'm saying? But in this case, our MX is lesser than our MCX, so that one passes like that. Our MY is lesser than our MCY, so that one passes like that. Move on to what? Step 4. Bele. Now, we are going to like 15. I told you I didn't give you all the steps. Are you with me at this point? Are you still with me? I hope I've not lost you. I know I've lost some of you. Now, All right, step 4. It says check cross-section capacity of section, right? What clause did I give you there? Oh yeah, let's go to that clause. 4.8.3.2. This is your first check. Sorry, your second check actually. 4.8.3.2. The formula there is FC over AGPY plus MX over MCX plus MY over MCY is lesser than or equal to what? 1. Now listen. If the answer of this, if it's greater than 1, you will start again from what? Step 2. I think I wrote that down. So let's start. What's our FC? What's our FC? First of all, what's the unit for AG? Centimeter cube in area. You change it to what? Millimeter squared. That gives 15,000. Your PY is what? Now, what's the unit of this PY? So you have to convert this to what? You have to convert kilonewton to millimeter. You have to convert your kilonewton here to what? To Newton. AG is in mm. This is actually in centimeter squared. But because this is in mm, this is in Newton per mm. We want to change this to what? Mm. I've already changed it like this to mm. Then this one is in kilonewton in the question. But remember that this one is in Newton. So we want to convert this to what? Newton. That's times 10 power what? 3. Now, what's our mx? What's our mx? 80. What's our mcx? For what? Just for a bit. What's our my? What's our mcy? All right, let's calculate this and let's check our answer.
Just like to embarrass them.
Let's check our answer. So this is our step 4. What did you get? 4 points. That's wrong. Your answer should give 0.712. Yes. So 0.712. Is it lesser than or equal to 1 or greater than 1? So this check is what? Okay. It passes, right? So you move on to what? Step 5. Yes. Hello. Orinla Oluwa. What can you not solve? So we go to what? Step 5. What does step 5 say? Good. So now, the name of this is what check? Cross. No, what's the name of this check? Check your step 4. Cross-section capacity check. So now, what we want to check for now is called buckling resistance check. All of these steps, from step 5 underneath, they are under buckling resistance check. So let me call it buckling resistance check. All right, good. Now, step 5. What does step 5 say? Effective length. Now, what will be the formula for your effective length? What table you go to? Table 22. So what will be the formula? Go there. 0.7L. Why? Because it is fixed and it is what? Braced. Did they tell you in your question? Did they tell you in your question? Yes. So your LE will give you what? 10,000. Do you understand? Yeah, I just come. I didn't mean that later. So what's the next step? Slenderness ratio. You know how to get that, right? What's the formula? You know, we are doing it in two axes, lambda ex and lambda ey. We are getting closer to the end. It's just like now. What's our slenderness ratio? Now, what is our Rx and Ry? Let's get that from your section table now. Let's get our Rx and Ry. Rx is what? 13.6. What's our Ry? 77 mm. 77.7, sorry. So let's calculate our slenderness ratio for x-axis. That will be 7,000 over. Are you with me? So what would this one give us? 51 point what? 90.09. Now, next step is what? Allocation of what? Strut curve. So let's go to our table. What table is that? Table 23. So now, get me your strut curve. B and C are B. Which one is B? So x axis is what? Do you understand how I got this? Do you understand how I got this? I know some people are normal with me. Hello, fine boy. I know you are normal with me. But you see that you just about hello, step out. Now, step 8.